everyone. Today, me and my teammates are going to present about the application of differentiation. Before we get started, let me introduce my teammates. The first one is Aisyah binti Badsha Hussain, and the next one is Alzajira binti Sinyu, and the third one is Frances Nimpeping, which is me, and the last one is Nur Hafizatul Fasihah. Right into the introduction. So, what is differentiation? Differentiation in calculus is the process of finding derivatives. The first derivative of a function y equals to fx is denoted dy over dx, where dy represents an infinitesimally small change in y and dx represents an infinitesimally small change in x, and it is defined by the picture shown. There are 8 techniques of differentiation, and it is the constant rule, the linear rule, power rule, sum rule, difference rule, product rule, quotient rule, and we have application of differentiation, and it is the rate of change, curve analysis, tangent and normal lines, maxima and minima, inflection points, and the last one is increasing and decreasing function. Related rates. Related rates problems involve 2 or more variables that change over time, often at different rates. By understanding how these variables are related and knowing the rate of change of one variable, we can determine the rate of change of the other variable. This involves writing an equation that relates the variables and differentiating it with respect to time, often using implicit differentiation. Next, what are maximum and minimum problems? Maxima and minima are found using derivatives. By locating points where the derivatives, also known as slope, is 0, known as turning points and stationary points, we can identify the local maximum and minimum value of a function.
For the problem statement, question number 1, a spherical balloon is being pumped with air at a rate of 16 cm3 per minute. Find the rate at which its radius is expanding after the balloon reaches a diameter. To answer this question, we must know that the volume of a sphere formula is V equals to 4 divided by 3 pi r cubed. With the given rate of change of volume 16 cm3 per minute and given rate of change of radius, first we should differentiate volume with respect to time. Apply chain rule, so the equation became fraction dv over dt 4 over 3 pi multiplied by dr squared fraction dr over dt. We can simplify the equation fraction dv over dt 4 pi r squared fraction dr over dt and substitute the given values. 16 equals to 4 pi multiply with 4.5 square fraction dr over dt and solve for fraction dr over dt. We will get 16 over 4 pi multiply with 4.5 square. Simplify the expression and we can get 16 over 81 pi centimeter per minute. The result shows that the radius of the sphere is increasing at a rate of approximately 0.0629 cm per minute. 2. About maximum and minimum problem. The question is, you plan to build your cat a box to sleep in. For the square bottom of the box, you intend to use plush material, which costs Rm2 ringgit per inch square. The size material is Rm1 ringgit and 50 cent per inch square. Your cat is larger than average, hence a 3000 240-inch cube box is required. Use X and Y to represent the length and height of the box. I will be explaining the answer for question number 8. Show that the cost C of the material is C equals to 2x squared plus 19,440 over X. We need to define variables and constants. X is the variable representing some dimension, which is length. Y is another dimension, which is width. The volume V equals to 3,240 R cubic inches. Cost per unit area for X are Rm2 ringgit per inch square, and cost per unit area for Y are 1 ringgit and 50 cents per inch square. Then the volume of the object is given by V equals to X squared Y, because it is probably a box with a square base. Given V equals to 3,240 cubic inches, we substitute into the volume equation 3,240 equals to X squared Y. Now we solve for Y. We arrange the volume equation to solve for Y, and we can get Y equals to 3,240 divided by X squared. For the cost equation, the total cost C involves the area costs of the sides. The cost includes 2 sides with area x squared and 4 sides with area xy. The equation of cost becomes C equals to 2x squared plus 4 cost per unit area for y side. Then we can substitute the costs given the cost per unit area for x and y are C equals to 2x squared plus 1.5xy. This simplifies to C equals to 2x squared plus 6xy. After that, we can substitute y with 3,240 over x squared into the cost equation. Simplify the fraction, and the final cost equation is C equals to 2x squared plus 19,440 over x. This equation represents the total cost in terms of
Question B, it asks to find the dimensions that will minimize the cost. So to solve this question, it requires 3 steps, which first step is to find the derivative. So from the equation A, we got the C value is equal to 2x squared plus 19,440 over x. So we got the derivative C with respect to x is equal to 4x minus 19,440 over x squared, or 4x minus 19,440 x to the power of negative 2. So we got this derivative using the differentiation rule. So after we got the derivative, we go to the step 2, which is let the derivative is equal to 0. So we let dc over dx equal to 0. We substitute the dc over dx value, so it becomes 4x minus 19,440 over x squared equal to 0. We move negative 19,440 over x squared to the side, it becomes positive, so it becomes 4x equal to 19,440 over x squared. Over x squared, we move to the side, it becomes substitution, so it becomes 4x cubed equal to 19,440. After that, we want the x is as a title, so we move 4 to the side, it becomes division, so it becomes x cubed equal to 4,860. And then we want the x value, so cube move to the side, so it becomes x equal to 16.94 inch. After that, the last step is second derivative test, which we differentiate again the derivative. Okay, so dc over dx that we got from step 1 is 4x minus 19,440 over x squared. So we differentiate again, it becomes 4 plus 38,880 x to the power of negative 3, or 4 plus 38,880 over x cubed. So when x equal to 16.94 inch that we got, substitute the x value into second derivative equation. After we calculate, we got the answer is 12, which is larger than 0. Since the second derivative test is larger than 0, therefore x equal to 16.94 inch is a minimum value. When x equal to 16.94 inch, we substitute the x value into y equation. After that, we got the answer for y value is equal to 11.29. Question C, it asks to find the minimum cost. So since we got the x value and we have determined x value as a minimum value, so we just substitute the x value into C equation, which is cost. So we got 1,721 ringgit 51 cents. So that's for the question C.
By applying differentiation method into this problem, we can conclude that the application of differentiation can be used to define a related rate, solve a maximum and minimum problems, and solve any other problems. Therefore, choosing the appropriate formula and accurately doing both first and second derivatives will result in a reliable response.